All right, so this is my repo for INFT 1207. Quick look at the structure. I've got source for all my Python and Selenium file, tests for unit tests and PyTests, and docs for the markdown stuff. Um, that's the whole project layout. And before I go into the WebDrive stuff, just want to confirm everything from the early class is still here. Moving on to the actual focus of the video. So this is the first WebDrive .py, my first real WebDrive script. Up top, you can see the version header. Um, it's it's pretty simple life cycle. I create a driver. I call .get and to navigate to automationexercise.com, and then I quit a browser. In the try finally block is I wrap the whole session in a try and finally. The reason is if anything goes wrong in that try block, an element isn't found, a timeout, whatever, I still want the browser window to close in the finally. Otherwise, you end up with the orphan Chrome process just sitting there eating memory every time a test fails. That's the whole point of try finally for WebDrive session. Guarantee cleanup no matter what happens. The real difference between Selenium IDE and WebDrive. IDE is a record and playback browser extension with basically no real program behind, while WebDrive is me writing actual Python code that control the browser directly, which means I get real logic, real assertion, and way more control. Okay, so this is the WebDrive demo.py. Um, Let me just run it. So this is where it gets interesting. So you can see you open the browser, maximize the window, navigate around. Those are just standard browser commands. I'm just gonna take you to the wait block. My expect way paired with an expect condition. So what it's actually doing is that 10 is not a fixed delay, it's a timeout ceiling. Selenium is going to check over and over every little bit whether the condition is true, like whether a element is visible or clickable. The moment it's true, it move on immediately. It only wait the full 10 seconds if the condition never become true in that window. And that's exactly why time dot sleep is wrong true here. Time dot sleep 10 just block for flat 10 seconds every single time, whether the page load in half second or 8 seconds. Best case, you are wasting time and make your test suite slow. Worst case is the page is genuinely slow that one time and 10 seconds wasn't enough. So your sleep runs out. The element still isn't there and your test fails anyway. And exploit way actually react to the real state of the page instead of just guessing a number. And last thing in this file is headless model. I'm using Chrome option and adding the headless argument so Chrome runs without actually popping up a visible window. Why would I want that? Mainly for running tests on a CI server where there's no display anyway. It's fast and it's the standard way you'd run a big test suite regularly. Now next is to the element locator .py. All six basic locator strategy. I'm not going to go through them all six on camera, but let me show you a few. So this one's located by ID. This is my go-to whenever the element actually has a unique ID because ID are supposed to be unique on the page, so it's the most reliable one. And there's to dog class name. I'd use this when there's no ID, but there's a distinct class. Though I have to be careful because a lot of elements can share the same class, so it's less precise. And down here it's linked text. These are specifically for anchor text, matching on the visible link, which is handy for nav menu and further links. And after each one, I've got an assertion check. The element state like the is displayed or enabled, so I'm not just locating the element. Quick look at the code quality. And here's the gutter of couple my web drive. Pretty clean, no major PPA flags. Um, I'm gonna take you to the GitLab commit history. And here's the commit history. You can see this wasn't a giant dump at the end. It's built up lesson by lesson. And that's it. Thank you for watching.